From Charlottesville, Virginia, this is Liam Wolf
and Sean Sequeira
of the iGEM team at the University of Virginia. This is how a plasmid becomes a drug. This summer, we set out to find a new therapy for diabetes. Here to tell us more about the disease is Dr. Susanna Keller, an endocrinologist at the University of Virginia Medical Center. Dr. Keller, can you explain for us what is diabetes?
The basic definition of diabetes is increased blood glucose levels. And increased blood glucose levels under fasting conditions that go above 100 milligrams per deciliter. And that's basically the definition. Or then when after a meal they go way beyond 140 milligrams per deciliter, and that's usually 2 hours after a meal.
We began to create a new device to reduce the severity of glycemic spikes for diabetes and hyperglycemia patients. Although by the end of the summer we may have been successful in creating a device which meets our objective of reducing the severity of glycemic spikes, our device still has a long road ahead before it will become a marketable biological therapy.
In producing a new synthetic or genetically modified medical therapy, there is a lot to consider. Firstly, there are a number of safety guidelines to follow mandated by Environmental Health and Safety, or EHS, at the University of Virginia.
For example, EHS prohibits researchers from adding antibiotic resistance traits to bacteria.
So, knowing what we can and cannot do in our lab due to the stringent guidelines imposed by the FDA and policymakers, how are we going to ensure that our bacteria will be safe in the human body?
Some of the factors we need to consider which would make our bacteria dangerous in the human body include lateral gene transfer of antibiotic resistance traits and mutation.
In order to combat these and other risks to human health and safety, we must ensure that we address these safety concerns through a number of methods.
We could implement a heat resistance gene into our bacteria rather than an antibiotic resistance gene to select for the bacteria with our gene circuit.
The risk of colonization can be mitigated through integration of additional gene or CRISPR-based kill switches and gene flow prevention.
Fast forward, and now the device has been successfully made and modified to be safe for users.
Before we can start distributing it to patients, it must be approved as a new medical therapy or biological by the Food and Drug Administration, or FDA. We spoke with Dr. John Herr, a professor of cell biology and biomedical engineering at the University of Virginia, who has been awarded over 25 patents on what it is like to get FDA approval for a new medical therapy. He gave us the following advice. Dr. Herr walked us through the FDA approval process.
A synthetic biology or genetically modified organism would have a different experience, though, if it were to try to get the same FDA approval.
We talked to Dr. Owen Fields, Vice President of Regulatory Science at Pfizer, on what it would take for a new synthetic biomedical therapy to achieve FDA approval, and he guided us through the process.
For the product, you'd have to file what's called an investigational new drug application. You would have to show a map that the product is reasonably safe to go into clinical trials. Once you showed it was safe in early clinical studies, you could then go to later stage clinical studies. Because this would be in diabetes, there would be what's called a good clinical endpoint for the product. Clinical endpoint is really something you measure in the clinic that you then you judge whether the drug works or not, and it would be regulated just it.
Dr. Fields additionally suggested that we opt to classify our product as a biological drug instead of a dietary therapy.
Probiotics are generally sold under the Dietary Supplement Health and Education Act.
Okay.
And the reason they can be sold, and they're sold over the counter, and the reason they can be sold that way is because they are considered normal components of the diet or normal components of the human body. If you were to engineer one of those, in this case it would be an E. coli strain, or it could be some other future, those would not be eligible for regulation as dietary supplements, and they would instead have to be regulated as drugs. So the product would be regulated as a drug. It would be, because it's a living organism, it would be regulated as a so-called biologic under what's called the Public Health Service Act.
We have explored many avenues our project can take after it has reached scientific maturity.
But, perhaps fortunately, there still remains a long road before our project reaches the market and the public.
The FDA, EHS, among other bureaucratic entities, require due diligence from all research groups to ensure that the new products work, are safe, and do not pose a threat to the larger society.
Will our project and its reduction of postprandial spikes be on the market soon? Only time will tell.